All right, number 17, we have a rational function and we want to find the limit as h goes to 0. So if you would notice when you plug in 0, we're going to get 0 on the denominator and that's going to cause a problem. So we're going to have to do something else. Usually when I see these problems that have a fraction within a fraction, I have a very particular method to use to solve these. Divided by h. Okay, so the method to the madness with this problem is you have a numerator that has fractions in it, and then you have a denominator. Now the denominator is just a whole number, so let's go ahead and make it a fraction and put it over 1. And when you compare numerator and denominator, there's a denominator in the numerator, and there's a denominator now in the denominator. So if you had a function down here, you can handle it the same. What I do is I look at each fraction as a separate term, and I try to find the common denominator between all three fractions. So I have 5 plus h, and then I have a single 5 term, and then the 1 is not going to affect it, but if it was a different number, we would use the 1 as well. So I'm going to take all of those denominators, and I'm going to multiply the top and the bottom. Now I've kind of been lazy, I'm leaving off the limit, but I really need to have this is part of the problem, but we're going to solve this algebraically first. So I'm going to multiply the top and the bottom by the common denominator between all denominators, or basically just take every single denominator and we're going to multiply it through. Now I'm not going to add the 1 because multiplying by 1 doesn't really change anything, but I'm doing that on top and bottom. Okay, when you multiply this whole term is multiplying times this term, and the whole term is multiplying times this term. The idea is when you multiply the 5 plus h, it reacts with the 5 plus h on the bottom, and they cancel each other out. So the only thing I'm left with is 6 times 5, which leaves us with 30. So I still have my limit as h goes to 0, and then this is now 30. This first part, when I multiply it, turned to 30. Then I do the same thing again. I'm multiplying this whole thing times this term. Well, in this time, the 5 divides out the 5, and then all I have to do is distribute the negative 6. You want to treat it as a negative 6 because of the minus. So I'll do negative 6 times 5, that'll give us a negative 30, and then negative 6 times h will give us a minus 6h. So we're going to subtract 30 minus 6h. And so that's what we get on the top. So the fractions have been eradicated. That was part of the goal. And then on the bottom, we're just going to multiply this times h. And for the moment, I'm not going to actually distribute it. I'm just going to leave it as separate terms. So I have h times the 5 plus h, and then times 5. So this is what we get. Now we can simplify. On the numerator, we got 30 minus 30. Those will cancel each other out. And so I'm just going to be lazy and write quotation marks. That just means bring down the limit. So 30 minus 30, we get 0. So on the top, we have a minus 6h, or negative 6h. And then on the denominator, we have the h, 5 plus h, and then another times 5. Since all of this is multiplied as one term, we can factor out an h on top and bottom, and then that leaves us with a negative 6, and then on the bottom we have 5 plus h times 5. Okay, so this is our first part, simplifying. And then once we have it simplified, we can now take the limit. So I'm coming up here, and now I'm going to take the limit as h goes to 0 of this new function, negative 6 divided by 5 plus h times 5. So if I plug in a 0 by direct substitution, this would just give me 5, and then 5 times 5 gives me 25. So we have a negative 6 for plugging in a 0. and we just end up doing 5 times 5, and that gives us negative 6 divided by 25 as our limit. Alright, so this one has two parts. They want you to first simplify. So once we simplified it, the furthest we got was here before we plugged in. So we're going to say negative 6 divided by, and I think they'll let me leave it as 5 plus h times 5. They may want you to distribute, but we'll see. Alright. And then once you evaluate the limit and plug in 0 with direct substitution, we get negative 6 divided by 25.